So question is here, find the value of this expression. Now as you know, you cannot cancel these two directly here because 13 pi by 6 is not in the domain of cos function. What's the domain of cos function? You know, close interval 0 to pi. So we need to reduce this angle in such a way that this should fall from 0 to pi, that is in first two quadrants. So we reduce this angle as we used to do in 11. So this is cosine nearest multiple of 6, which is 12 pi plus pi by 6. Such things we did in 11. So this is cos inverse cosine, you know, 2 pi plus pi by 6. This step you can write directly from this. Now 2 pi plus alpha, 2 pi is same as 0, so it will be in first quadrant. They're all trigonometric functions are positive, so this is cosine pi by 6. Now this will get cancelled, so answer is pi by 6. If you write directly answer from this 13 pi by 6, it will be wrong, remember. This value should be in the domain of cos function. So whenever you cancel inverse and function, you need to see that whether appropriate value fall in the domain or not. Same way, if I go to the second question, tan inverse tan 7 pi by 6. Now you recall what's the domain of tan function? It is open interval minus pi by 2 to pi by 2. 7 pi by 6 is not in this domain. This is either first or fourth quadrant. 7 pi by 6 is in third quadrant, so you cannot cancel these two directly. So we need to reduce this angle, and you know that this you can write as pi plus pi by 6. That much we know. Pi plus pi by 6 is just 7 pi by 6. Now here pi plus alpha, so it will be in the third quadrant. In third quadrant tan is negative, so this is tan is positive, so this 10 pi by 6. Pi plus, it will be in third quadrant, there tan is positive, so we have this. Now again you can cancel this two, so your answer will be pi by 6, and pi by 6, you know, it is in the domain of tan function, that is open interval minus pi by 2 to plus pi by 2. So pi by 6 is your answer here. Now question number 3 onwards, we want to prove this. So question number 3, prove that 2 times sine inverse 3 by 5 equals to tan inverse 2 by 7, 24 by 7. We want to prove this. So what we do in such questions, in almost all these proofs, we use this property. We use tan inverse x plus tan inverse y. We use everywhere equals to, you know, tan inverse that expression. So I'll start with LHS here. Twice sine inverse 3 by 5, and using that inverse relation of inverse Trigo functions, this I can reduce into tan inverse. So you draw a right angle triangle here. Sine, you know, it is opposite upon hypotenuse, so this will be by Pythagoras, you know, 4. So what is tan inverse from this? It is opposite upon adjacent, so 3 by 4. So this become now tan inverse 3 by 4 plus tan inverse 3 by 4. So this is tan inverse x plus tan inverse y, and remember here x into y, it is less than 1. 3 by 4 into 3 by 4, which is less than 1. So this is equals to tan inverse 3 by 4 plus 3 by 4 upon 1 minus 3 by 4 into 3 by 4. Now you just simplify this. So here tan inverse, you will get 12 plus 12, 24 by 16 upon 16 minus 9, which is 7 by 16. So finally you will get tan inverse 24 by 7. That is your RHS. So same way here, like previous question, we reduce both of these into tan inverse. So draw a right angle triangle, draw a right angle triangle. Sine means opposite upon adjacent, opposite upon hypotenuse. So by Pythagoras theorem, this will be 15. 17 square minus 64, so we'll get 225, which is 15. Here opposite upon hypotenuse, so by Pythagoras this will be 4. This you got by Pythagoras. So from this, tan inverse opposite upon hypotenuse, so adjacent 8 by 15 plus here tan inverse opposite upon adjacent, which is 3 by 4. And then now you use this result, tan inverse x plus tan inverse y. And here remember, x by y is less than 1. So if you use this formula, tan inverse here 8 by 15 plus 3 by 4 upon 1 minus 8 by 15 into 3 by 4. Let's use this. If you use this and simplify, you will get the tan inverse 77 by 36. You simplify this, you will get this, which is RHS. Next, question number 5 here. Their left hand side is cosine inverse 4 by 5 plus cos inverse 12 by 5. 12 by 13, sorry. And you want to get cos inverse 33 by 65. This is what you want. So the first task is you reduce both of these into tan inverse. Right angle triangle. Cosine means adjacent upon hypotenuse. So the opposite side would be 3 by Pythagoras. Here cosine means adjacent upon hypotenuse. So this opposite side will be by Pythagoras 5. This we are getting by Pythagoras, remember. This is 3 by Pythagoras. Okay. So here tan inverse opposite upon adjacent 3 by 4 plus tan inverse, here you will get the 5 by 12 opposite upon adjacent. Now let's use that formula here, 3 by 4 into 5 by 12, which is again less than 1. This product will be less than 1, so we use that formula, tan inverse 3 by 4 plus 5 by 12 upon 1 minus 3 by 4 into 5 by 12. X plus y upon 1 minus xy. So this is equals to tan inverse. We take LCM. 12 3s are 36 plus 20 upon 12 4s are 48 minus 15. I repeat, so this 48 will get cancelled. 12 3s are 36 plus 20, 48 minus 15. So this is equals to here tan inverse. You will get 56 upon 333. 48, so 8 minus 5 3 4 minus, so we will get this. Now you want RHS in form of cos inverse, remember. So reverse the procedure here. So we again draw a right angle triangle. If I draw a right angle triangle here, you are given tan. Tan means opposite upon adjacent. So by Pythagoras theorem you can find this, and this would be 65. You can verify. Tan means opposite upon adjacent, so this you can find by Pythagoras, which would be 65. Root of, you can verify, root of 56 square plus 33 square, which would be exactly 65. This much you can verify. So now again you write the cos from this, so because we want the cos function here, remember. So cosine inverse adjacent upon hypotenuse, which is 65. So that's your RHS. So here we use tan inverse x plus y, here tan inverse x plus tan inverse y. So from this we'll get the tan inverse 1 by 5 plus 1 by 7 upon 1 minus 1 by 5 into 1 by 7. Same way here, tan inverse 1 by 3 plus 1 by 8 upon 1 minus 1 by 3 into 1 by 8. Now you simplify this, you will get the tan inverse one expression plus tan inverse another expression, and in turn again you use tan inverse x plus tan inverse y. So if you use this here, this plus this upon 1 minus this into this, so at the end you will realize you will get the tan inverse 1, remember, and tan inverse 1 is just pi by 4. That is your RHS. So next question you are asked to prove this. So obviously we start with RHS here. So right hand side is 1 by 2 cosine inverse 1 minus x upon 1 plus x. Now you know this formula. Outside your cos inverse, if you remember, cos 2 alpha equals to 1 minus t square alpha upon 1 plus t square alpha. We know this. 1 minus t square upon 1 plus t square. So it means you need to put x equals to tan square theta alpha substitution. So put x equals to tan square alpha substitution. Why we are using this? Because we have this formula. So cos inverse and cos will get cancelled. So 1 by 2 cosine inverse 1 minus tan square alpha upon 1 plus tan square alpha. So this becomes, you know that as I've shown here, this becomes cos 2 alpha. So this is 1 by 2 cos inverse cos 2 alpha. So this will get cancelled now. So you are just left with 1 by 2 into 2 alpha. So that is just alpha. Now go back to substitution. As x equals to tan square alpha, so root x equals to tan alpha. So what is alpha from this? Which is tan inverse. So tan inverse root x, which is nothing but LHS. So now here, this is again an important example. Outside your cot inverse, so this should be reduced either in cot or tan. Now if you recall from 11th standard, you know 1 plus sin x can be expressed as cos x by 2 plus sin x by 2 the whole square. If you remember, you just expand it, you will realize you will get exactly this. This is from 11th standard. So instead of 1 plus sin x, we are going to put this, and instead of 1 minus sin x, we are going to put cosine x by 2 minus sin x by 2 the whole square. Remember, you just expand by a minus b formula, whole square formula will get exactly this. A plus b whole square formula, if you expand, you will get exactly this. You can just check this. This is from 11th standard. And you also know that the root of 1 plus sin x become modulus cos x by 2 plus sin x by 2. And this would be in the first quadrant only. So this is positive. So it is just cos x by 2 plus sin x by 2. And here root of 1 minus sin x will be again cosine x by 2 minus sin x by 2. So this is cos x by 2 minus sin x by 2. So I'm putting all these things there inside the bracket. So cot inverse cos x by 2 plus sin x by 2 plus this expression, which is cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. Just placing these values, so you can see that this will get cancelled, so this is twice cos x by 2. If you open the bracket, cos will get cancelled, this will be plus, so this is twice sin x by 2. So this is cot inverse, this is cot x by 2, and again cot inverse and cot will get cancelled, so this is x by 2, which is what you want on the RHS. So this is right hand side. Okay, so here this is again very important example. You have tan inverse this expression, outside tan inverse, so inside you must have tan. Now you have both the factors here, minus and plus. So what I'll do, the first step I'll do like this here, dividing both by root 1 plus x. So here 1 minus root 1 minus x upon 1 plus x upon 1 plus root 1 minus x upon 1 plus x. Why I did like this, that you will realize now. What I did, dividing both numerator and denominator by this factor. So here 1, here root 1 minus x upon 1 plus x, here root 1 minus x upon 1 plus x. Now if you remember, this is a known formula, 1 minus cos theta upon 1 plus cos theta. So I'll put the substitution here, x equals to cos, you can just put theta or 2 theta. So if I put this 1 minus cos 2 theta upon 1 plus cos 2 theta, you know that this is root tan squared theta, and root tan squared theta is just tan theta, that you know. So at this place, tan inverse, this is 1 minus tan theta upon 1 plus tan theta. Now we already used this concept earlier. This is just a known Trigo tan formula. So this you can rewrite as here tan of pi by 4 minus theta. We already used in earlier one of the example. This you can write tan pi by 4. So it's like tan pi by 4 minus tan theta upon 1 plus here into 1, that you can write tan pi by 4 into tan theta. You know that this is just tan alpha minus beta, so tan pi by 4 minus theta. So we have this. Now this will get cancelled again. So this is just pi by 4 minus theta. Now to find the theta, go back to substitution. So here x is cos 2 theta. Take cos on the other side. So cos inverse x equals to 2 theta. So theta will be 1 by 2 cos inverse x. Represent theta here. So this is pi by 4 minus 1 by 2 into cos inverse x. This is what exactly you want on the other side. Pi by 4 minus 1 by 2 cos inverse x. That is RHS. So we want to prove this. So what I'll do, I'll take this expression on right hand side. So I'll write RHS as take 9 by 4 common. So this is sine inverse 2 root 2 by 3. This is sine inverse 1 by 3. Now this by right angle triangle you can reduce into 10. This you can reduce into 10. So 9 by 4 tan inverse, you know this, plus reduce into this, so tan inverse, which also you know. Then use tan inverse x plus tan inverse y formula. So 9 by 4 into, you get the tan inverse, that expression that you know. And at the end you will notice that probably you will get the 9 by 4 into tan inverse 1. And you know that tan inverse 1 is pi by 4. So here not 10, you want 9 pi by 8, no? So probably this would be undefined, and it would be pi by 2. You will see that, you know, 10 pi by 2 is undefined here. So you will notice that this would be undefined, and tan inverse undefined would be pi by 2. So this is 9 pi by 8. This is your right hand side. So here we want to solve these equations. That means we want to get x. We want to find x. That's the question. So you know, we start with both the sides. This is tan inverse cosine x plus tan inverse cos x. That's the only way to handle LHS. On the right hand side we already tan inverse outside, so we keep as it is. Now tan inverse x plus tan inverse y, which is tan inverse cos x plus cos x upon 1 minus cos x into cos x. You know which formula we have used. X plus y upon 1 minus xy. Right hand side again as it is, twice cosec x. Now this tan inverse and this tan inverse you can cancel from both the sides. So this is twice cos x upon 1 minus cos square, which is sine square, and this is twice cosec x. Now this is purely reduced into Trigo functions. Cos twice 1 minus cos square, which will be sine square, and twice cosec x. So the next step will be, this is twice cos minus sine, cos by sine into 1 by sine equals to twice cosec x. So this is just cot x. 1 by sine is cosec, and cosec will get cancelled, 2 will get cancelled, so this is equals to 1. So therefore tan x equals to 1, just taking reciprocal. And you know from 11th standard the solution set for tan x equals to alpha. In general, you know this is x equals to n pi plus tan inverse alpha. This is from 11th standard. So here x equals to n pi plus tan inverse 1. So this is n pi plus pi by 4. You know tan inverse 1 is pi by 4, where obviously n belongs to z. So this is the solution set of above inverse trigonometric equation. Tan inverse 1, so x equals to n pi plus tan inverse 1 here. This is from 11th standard, if you recall. Next question, 14 number. Tan inverse 1 minus x upon 1 plus x equals to half tan inverse x. Again here question is get x, find the solution. So tan inverse 1 minus x upon 1 plus xy. Now this is like x minus y upon 1 plus xy. It's like this, 1 minus x upon 1 plus 1 into x. So it's like x minus y upon 1 plus xy. So here x is 1 and y is x. So this you can write as tan inverse 1 minus tan inverse x. You do the reverse, you'll get exactly this. Tan inverse x minus tan inverse y is tan inverse 1 x minus y upon 1 plus xy. I hope this is clear to you. Equals to 1 by 2 tan inverse x. So it implies, you know, this is pi by 4. I'll take this one on the other side. So 1 by 2 tan inverse x plus tan inverse x. So pi by 4 equals to half plus 1, that is 3 by 2 tan inverse x. So it implies this is nothing but, if I simplify, pi by 6 equals to tan inverse x. So therefore x equals to tan pi by 6. And you know tan pi by 6 is 1 by root 3. So here x is 1 by root 3. Again emphasize on this formula. I've used this one, remember. Tan inverse x minus y upon 1 plus xy equals to, you can write tan inverse x minus tan inverse y. You know here x is 1 and y is x. Using that you are getting this from this, remember. The other things are clear from the steps. So we want the simplification of this. So obviously this tan inverse should be reducing to sine. So draw a right angle triangle. As you know, tan means opposite, you can imagine by 1. So opposite upon adjacent, so 1. So if you use Pythagoras here, this is root of 1 plus x square. This is by Pythagoras. So sine as it is. I want sine function, sine inverse. So it would be opposite upon hypotenuse. So x by root of 1 plus x square. So this will get cancelled now. So it is just x upon root of 1 plus x square. This is option D. 16 number for you, you can try. I'll go to last 17 here. So now the last question here. Tan inverse x by y as it is. Now here, to get the same expression x by y, what we do? We divide numerator and denominator by y here. So x by y minus 1 upon x by y plus 1. Dividing numerator and denominator by y. Why we are doing this? Because we want x by y. So this is tan inverse x by y as it is. You take minus common from this. So this is plus tan inverse. Here 1 minus xy upon 1 plus xy. Why we did this? You will see in the next step. Let me tell you what I did here. Taking minus common. So I've used this property indirectly. Tan inverse, if I take minus common, it's like minus x. So if I take minus outside, it becomes minus tan inverse x. From tan inverse, you know, you can take minus outside. So this minus common. So here you have 1 minus xy and that minus become plus. Okay. Now you already done such things twice. This is like x minus y upon 1 plus xy here. So this tan inverse x by y as it is plus, you imagine this is like x and this is like y. So tan inverse 1 minus tan inverse x by y. You do reverse. So if you use this formula reverse way, like tan inverse x minus tan inverse y equals to, this is like x, this is like y. So your next step will be tan inverse x minus y upon 1 plus xy. So if I write from this step, you will realize further. So finally this 2 will get cancelled. You are just left with tan inverse 1. You know tan inverse 1 is pi by 4, which is option C.